Hello everyone, welcome back to my YouTube channel. I'm Viraj and today we guys are going to see inheritance in a object-oriented programming. Inheritance help us to access the parent class properties into the child class. Here the properties is nothing but the attributes and method which we can access in a child class. That is going to be single directional, means parent class cannot access a child class property where child class can access all the properties of a parent class. We can have more than one class in an inheritance, where parent class is also called as a base or super class and child class is also called as a sub or derived class. We can see that there are 5 types of inheritance available in Python: single level, multi-level, multiple, hierarchical and hybrid. Let's see one by one. In a single level, we have A to B relationship, where A is a parent class and B is a child class. B can access all the properties of A class, but A cannot access a B. Even the implementation will, if you see that, so class A, right now we are writing a pass means it doesn't do anything. Class B, opening closing parenthesis, and we have written A. That means it is inheriting all the properties of A class and pass. So this is how we have defined inheritance. Let's see next, multi-level. In a multi-level, we have A to B and B to C relationship. A is a parent class for a B is a parent class for a C. So we can say that C is a child class for a B. C can access all the properties of a B as well as an A. B is a child class for A, so B can access all the properties of A class. And the implementation that we can do, class A, class B, opening closing parenthesis A, and class C inheriting B. So indirectly we can say that C can access A's property as well as B's property. This is how the multi-level inheritance is implemented. Then we can have a multiple. In a multiple, we have more than one parent class and single child class. So here A and B are a parent for a C. So C is a child class. So the implementation will be class A and class B independently. A and B are not connected, or they are not going to access each other property. Only C is accessing all the properties of A and B. Here we need to understand MRO, method resolution order. So if there are two common methods, like for example in a class A and class B, there is a show data method, and from a C class, if you are trying to access class A and class B's method, so first preference will going to be child class. If it is not there, then it will go to the first parent, which is A. Otherwise it will go to the B. If it is not found in both the parent class, then it will throw an error. That we will see more in a practical session. So this is how we can use a multiple level inheritance. Then hierarchical. In hierarchical, we have a one parent and multiple child class. So A is a parent for a B and C. B and C are not connected, means they cannot access each other properties, but B and C are accessing or pointing to the A, means they can access all the properties from A class. And the implementation is something like class A pass, class B opening closing A pass, class C parenthesis A. So C and B are pointing to the A. So C and B are a child and A is a parent. And the last and most interesting is a hybrid. Hybrid is a combination of more than one inheritance type. So here we can see that we are having a multiple and hybrid. We can say that hierarchical inheritance, the combination of both. So A is a parent class for a B and C. Then B and C are a parent class for a D. So indirectly we can say that D can access a B, C, A, means it can access all the properties of B, C, A. Okay, so this is how it is going to happen. And the implementation will be class A pass, class B is inheriting all the properties from A, then class C, which is again inheriting all the properties from A, and class D, then it is pointing to the B and C. So B is a parent class and C is parent class for a D. Here only one thing that we have to remember, MRO, method resolution order, which we are going to see in detail when we are going to write a practical code. Okay, so let's see inheritance in OP. So first inheritance type we are going to see, that is a single level. In single level we are having a relationship like A to B relationship. Okay, so class A, for example, if I'm doing something like show data self print, I am in show data. Class B inheriting A, and if I am writing something like a print data, if I am writing a print data self print, I am in print data. So both the classes are having a one method each. So show data and print data. So what we can do, we can create an object of a B1 of a B, print dir B1. We can see one thing over here, print data as well as the show data. Print data is a local method for a B class, whereas show data is a method for a parent class. How we are denoting a parent? So like something like inheritance is denoted with the opening closing class name. This is how we can say the B is inheriting all the properties of a class. Help B1. So guys, we can see over here method resolution order, MRO. So we can see this B and A. Means first, whenever we are calling a B1 dot something means attribute or method. So first it will get checked in a B class. If it is not found, then it will go to the A class. And even though it is not found, then it will throw an error. So we can see that method defined here, print data, method inherited from A, show data. So this is how we can understood this particular concept. B1 dot print data, we will get output. I am in a print data. B1 dot show data, still I will get output. I am in a show data because B is a child class for A. So this is how the single level inheritance is implemented. We can take the same example and we can just add a few attribute over there. We can add an attribute num equal to 100, and I can just write a one more line, print value of a num is self.num, b1 equal to b, b1 dot num we can do this, b1 dot show data we can do this, b1 dot print data we can do this, print dir b1. We can see that num, print data, show data, help b1. Method resolution order remains same, b and a, method defined here, inherited here, but one thing, that is attribute or data and other attributes inherited from a will be num equal to 100. So this is inheriting from a. So guys, even though if you understood the documentation or how to use this built-in keyword help, then entire journey of a Python is going to be smooth and fine. So this is how the single level inheritance works. Okay, so now let's see the multi-level. In a multi-level, we are having a relationship like A to B and B to C, B to C. So this is how the relationship is going to go. Okay. So class A, if I'm saying a num1 equal to 100, def show data self print, I am in show data. Class B inheriting A, num2 200, def print data self print I am in print data class C, then inheriting B num3 equal to 300 def test data print I am in test data. So the implementation is something like A is a parent class for B, B is a parent class for C, and C is a child class for B, B is a child class for A. So this is what we have to understand: opening, closing, class name, opening, closing parenthesis, and inside that class name. Okay, we can create an object of a C class. Now if we do the print dir C1, so we can see this: num1 is accessible, num2 is accessible, num3 is accessible, print data, show data, and test data. All these things are accessible. So we can do something like c1.num1, c1.num2, c1.num3, c1.show data, c1.print data, and c1.show data. So we can see that with the inheritance, we can reduce duplicate lines, or we can reuse the code. So the entire motive of having an object-oriented design is a code reusability. So next we will see multiple. In multiple level, we are having the A and B, which are going to point to the C. So C is a child class, and A and B are a parent class. So there are more than one parent class are available. And here we just wanted to understand a MRO concept more betterly. So class A, I will design it num1 equal to 100, or I will make it as example number 1. Okay, def show data self print I am in show data class B num2 200 def print data self print I am in print data, and class C, which is inheriting A comma B, num3 equivalent to 300 def test data I am in test data. So as soon as I am creating an object of a C class, so dir or print dir C1. So we can see that num1, num2, num3, print data, show data, and test data. The interesting part that we have to see over here, that is a help documentation. Method resolution order. So C is first, means whenever you are accessing any attribute or method, first it is going to check for a child class or owner of that particular object. Then it will go to the parent. So first parent is A, and then it will go to the B. So even we can see that method defined here, attribute defined here, inherited from A, attribute inherited from A, inherited method from B, and attribute inherited from B. So this is the sequence that we have to understand. So method resolution order will always go from a left to right hand direction. So on a left hand side, first element is a C, or first class is a C, then it will go to the A and it will go to the B. So we will understand this in example 2 and 3 more in detail. Okay. So example number 2. This time what we are going to do, we are going to create a same hierarchy, same kind of classes, num100 def show data self print show data A class, class B num1 500 def show data self print show data B class. And lastly, class CA comma B num2 1000 def print data self print data C class. So now there are attribute name and method name are same in a both the parent. So as soon as I'm calling c1 dot num1, which num1 will going to get called, whether it will print 100 or whether it will print a 500. The answer is really simple. So first it will c1 dot num is going to check whether I am having a num1 or not. So there is no num1 available, means there is no attribute available in a C class. So it will go to the next, so it will go to the parent. So first parent is a, so it will go and check, yes, it is available, and it will dump it 100. It will dump the 100. It will dump the 100. The way we have defined it. Similarly, if I am doing a show data, so it will print a show data A class. So guys, we will take the same example. So just pay attention over here. So example number 3, and we will just do the one minor modification, or before doing that modification, let me do the help on top of it, C1. So we can see this method resolution order, MROCAB and all the stuff. Same code I'm going to copy paste it. Only one minor change that we are going to do, B comma A. Now C1 dot num1. Now what will happen? The num1 is available in a C class? No, it is not available. Who is the next parent? Next parent is a B. So it will go here and just do the something like num1 equal to 500. So as soon as we are running this, we will get a 500. And similarly, C1 dot, if we are doing something like a show data, so what it is going to do, it is simply going to say show data B class. So this is how it is going to work. So the change or entire workflow will get changed basis on the method resolution order. Even if you do the something like help C1, so we can see that CBA, C is a owner or the object we have created, then B is a first parent and A is a second parent, and the entire thing is remain same as it is. Okay. One interesting part that we can see over here, if we are having a same attribute and method, so it is not going to display their name. Method inherited from A is a show data and attribute is a num1. So we cannot see the for B. Similarly here, we are able to see only for a first parent, for a next parent, if the attribute and methods are the same, we cannot see the attribute and method in a help documentation. So that is the thing we have to take care. Even if we do the print dir, C1, so if you see carefully this, so we can see this num1, num2, print the data, show data. So like num1 is only one time, right now it is going to point to the B, and show data is going to point to the B only. So it is not, we are not going to have a duplicated values. So let's see hierarchical. So next thing that we are seeing, that is a hierarchical inheritance. In hierarchical, we are going to have a parent like A and the child class B and C. So this is how it is going to be, hierarchical inheritance. So let's continue the same examples like class A, class B and class C. So class A, num1 100 def show data self print show data. Class B inheriting A, num2 def show, or we can write a print data, print data class C inheriting A. Def test data. I am in test data. So we can see that only one parent and two child. So B and C are not having any relationship. B and C are not connected to each other. They are pointing to the only A class. So as soon as I am doing something like C1 equal to C print dir C1. So we can see that num1, num3 show data and test data. These are attribute and methods we can access it. Similarly, B1 equal to B print dir B1, and we can access a num1, num2 print data and show data. So this is how we can do it, guys. So C1 dot num1 we can access it, C1 dot num3 we can access it, C1 dot show data we can access it, and C1 dot test data we can access it. But if we are trying to access a print data, we will end up with the error. Because this particular C object is not having a print data. Means indirectly we can say that C class is not having a print data, or not even a parent class is not having a print data. Only the B class, and they are not having any relationship over there. Similar thing goes for a B1 dot num1, B1 dot num2, B1 dot num3. Num3 is available for only C class. Only for a C class. So, and B object is not having any relationship with the C class. So that's why we are getting this particular error, attribute error. Here also attribute error. So print data was not present and num3 is not present. So this is how we can access a hierarchical inheritance. Hybrid inheritance is a combination of a more than one inheritance type. So we can say that it will be the combination of a multi-level, multiple, hierarchical, multi-level. So all this combination will become a hybrid inheritance. So where we use more than one inheritance type. We can use something like this. Okay, so here we can have A is a parent for a B and C, and D is a child class for a B and C. B and C are a child class for A. Okay, let's see. So class A, again num1 equal to 100, def show data self print I am in show data. Class B inheriting A, num2 200, def print data print I am in print data. C inheriting A, num3 300, def test data self print I am in test data. Class D inheriting B comma C, num4 400, def dump data self print I am in dump data. If we are creating object of a D, so D is capable of accessing a B class property, C class property, and even A class property. Print dir D1. We can see this. Dump data num1, num2, num3, num4, print data, show data, and test data. Help D1. We can see the method resolution order. D to B, then C, and then A. So first it is going to check in a D. If it is not available, then it will go to the B, then it will go to the C, then it will go to the A. And similar thing is defined here as well. So you can try and experiment all these things. So for you guys, I will just quickly type this d1.num1, d2.num2, d1.num3, d1.num4. Similarly, show data, d1.print data, d1.test data, and d1.dump data. So guys, this might be a stupid examples for you, but for sure we are going to write an entire banking application kind of thing in coming session or coming videos. So where we are going to cover all the aspects, like where to use a single level, where to use a multi-level, multiple, hierarchical, hybrid, all these things we are going to cover. But to understand this concept, so these are the simplest way that I can explain you, where we are having a class A, class B, and class C kind of structure. So this will help you to understand the concept betterly, how the attribute method works, how the inheritance happens, and overall. So guys, thank you for watching this video. See you in a next.